Hello, Josh James here with Circles and Ellipses, friend or foe. So let's start with circles, since they're going to be able to learn more about circles and then at first, and then we'll go into ellipses so we can figure out the difference between the two. So a circle, we've all seen them around before, but the exact definition is going to be a round plane figure whose boundary consists of points equal distance from a fixed point. That's fixed point, or the center of the circle is going to be represented by AB here on this graph that we have on this picture. And then R, which is the radius, is a point from every single spot on the circle to the center is going to be the exact same, which is the radius, and then all the way across is the diameter. So here we have the equation of a circle. And the equation of a circle is r squared equals the quantity of x minus h squared plus the quantity of y minus k squared. So what this is showing here is that our x is going to be this point here, which is h. So the opposite of h, actually, because it has the minus sign. And then you have our y, which is going to be up and down, minus k, so the opposite of what it would be here, squared. And then, so when we actually get to the part when we're trying to graph a circle, we're going to remember that when we see how much is on the one side, that part here in the equation is actually going to be squared. So if it's 4 across, that part here on the r squared is going to be 16, because that really means that it's 4 across in here. So let's get started with this example here. So it's kind of hard to see here, but here we can see the center here marked with this black dot. It's this way 2, -2, and then it's going to be up 6. So how we're going to put that is going to be a little bit different than what you would think. So because it's -2, it's actually going to be showing in here, be showed as a +2. But for right now, we're going to put it as a -2 to the x, towards the x. And then for y, it's going to be up 6. So that is just going to be a 6. We'll put that in parentheses. So, and then we'll move over here, so it's right here, and change it to that same color. Or something like that. Okay, so now look at the radius. So we know the center is at -2, 6. So now we can go off any of these points here, because all the distances from a point on a circle are going to be the same to the center. So it doesn't really matter where we go from. But it's going to be easier to go from any of these dots here, because they're points on the graph. Okay, so let's go from this one here. If we go over here, 1, 2, 3. So it's going to be 3 over, and then 1, 2, 3, 4, 5, 6 up. So really, we can just see that when we see that it's at 3, we can find that it's 3 over. So we can take 3 and the -2 and get that it's 5 here. So this distance right here is 5. Right here is 5. Forgive me for my drawing there. Let me retry that. 5. Okay, so let's get our little handy dandy text box out and we put that in there. The radius is 5 over. So now we're going to put this in an equation. So when we look up here at our handy equation we have written out, we see that it's going to be r squared equals x minus h squared plus y minus k squared. Okay, so how we're going to write that is r squared. So our radius here, we're going to put that in as it's squared. So 5 squared, or 25, equals x minus, our x here is going to be -2, but we see that it's a negative anyways. So now since we have two negatives, that's going to be a +2, and that's why we have to flip the signs there. And then that is going to be squared, so we'll put that in there. And then we're going to add our y to that. So what, parentheses, and then we know that our center is at 6. So once again we have that negative there. So we're going to change that to a -6. Y minus 6 squared. Okay, and that's going to be the equation of this circle here. Okay, So let's move on. Let's try going the other way. So now we have, right here, we have the equation. Here's the equation of what's going to go on this graph here. So once again, from our equation up here, I'll even move it down for us so we can see it better. Oh, you know what? Maybe we won't. Just not wanting to come with me today. Okay. So, but we can still see it here, r squared. So first thing we need to find out, we need to find the center of it. So the center is going to be these points here, as we can see, because that's where x minus h, that's going to be the x spot, and this is going to be the y spot. Except for it's going to be the opposite of what it shows, because they're inside of parentheses. And the way I remember that is, if you have a couple in, say, a high school, and they're behind closed doors, like these parentheses, then you probably can't trust them. So they're going to be doing the opposite of what they say. So this -2 is actually going to be a +2. So let's get a brush out here and mark that. Okay, so +2, and then we have, once again, a -2, and you can't trust them because they're behind closed doors. So that's going to be up here at 2, +2. So that's our center of the circle. So now we got to figure out where the points from this are going to be. So we have 4 here. So this is going to be what the radius is squared. So we got to square root that to find how far it be. And 4 square root equals 2. So it's going to be 2 away from every one of these. So 1, 2, that's going to take us to this point, which is going to be 4. And then back 2 is going to take us to the origin. Up 2 is going to take us to 4. Back 2 is going to take us to here. And when I said origin, I actually meant 0, 2. So now I'm going to do my best to go ahead and fill this in. So we get this circle here. Okay, it's not the best, but you get the general idea. So now we know how to take the equation and graph it. We know how to take the graph and get the equation. So now let's say we don't have let's say we don't actually have either of those, and we just have the equation, but it's not quite in the equation form yet. So here we have 2x squared plus 2y squared minus 20x plus 16y plus 74 equals 0. So I encourage you to go ahead and pause this and see if you can't figure out how to solve this. But for now, since you have already tried that and on pause, I'm going to go and get started on it. So to do this, you have to do this through completing the square. And if you don't know what completing the square is, then you need to go ahead and see if you can't go find a video on it, and we'll post a video on it as soon as I get the time for that, and you can be able to watch that one. But for now, I'm gonna go through this like you already know how to complete the square. So the first thing is we're gonna take these and we're gonna go ahead and separate them out. So we get 2x squared minus 20x. So we're going to take that, put it out of standard form where the squared would go first, and then the just the x's, and then the constant would be there. So let's put that in parentheses. Okay, and then we're going to take our parentheses. We're going to add these together actually, and our 2y squared plus 16y. Okay, and we're going to actually have that 74 left out all by itself for now. Okay, so this is going to be your first step here to get started where we're going. Let's change that to maybe a different color. I like blue. Okay, and plus 74. Okay, so now that we got these separated out, it's all equals 0 still. Okay, now we're going to actually subtract that 74 over. So we're going to subtract the 74 over. So we get that it equals negative 74. Okay, and now we still have the 2x squared minus 20x plus 2y squared plus 16 equals negative 74. But now the next step in completing the square is going to be to take this 2 out. So let's go ahead and do that. I'm going to take the 2 out of each of these equations. So when I take the 2 out here, I get the 2 is going to be outside the parentheses. Is this going to be x squared now? Minus 10x, because I took a 2 out. And I still have the x in there because I could only take out the 2, not the 2x. Okay, and then I'm going to do the same thing for the y. I'm going to take out that 2, and we're going to get y squared plus 8 now. 8y, actually, equals negative 74. Okay, so now we have that. So let's put that over here so we get our progression of our steps going. Okay, so the next thing we're going to have to do is then we get to the more the completing the square part. So we're going to take half of what this term is right here. Right here, we're going to take half of it, of these two terms, and then we're going to square it. And that will always be a positive number because we're squaring it. So let's go ahead and do that step. So we still have our 2 out there, but now it's going to be x squared minus 10x plus 25 because we're doing that. Now, something important to note here is that this is where the x squared part is actually going to be able to go out to the half there because we're completing the square. So this actually is where we're going to go to this part. Or at least that's where it makes sense for me to go ahead and switch over. So now that this whole thing is squared. Okay, and now we're going to do that for the y. So we have 2 out there because it's still out there. Y, because we're going to get rid of that y squared and put it all squared now. And then we're going to have our plus 8y. And then half of 8 is 4. And then 4 squared is 16. So now we're going to have that 16. This is all going to be squared now. And it still equals negative 74. Okay, so now that we have that, let's go back to blue. The next step is that we're going to have to take these and put them on the other side there. Because if you see, for our equation right here, we just have these terms here. We don't have the full 3. So we need to get the other side there so we can figure out what exactly our radius is going to be is what we're trying to figure out by getting these over here. But before we can do that, we still have this 2 out here. So before we move them towards the other side, we have to multiply this 2 times that. And multiply this 2 times that before we move them just straight over. Okay, so 2 times 25 is going to be 50. And 2 times 16 is going to be 32. Okay, so 50 plus 32 is going to be 82. So we're going to actually add that 82 over here. We're going to take that 82 over here. If I can write an 8. Just bear with me. 82. So that's actually going to equal 8 now when we get that added together. So now it's just 8. Okay, so let's rewrite that whole equation now so we can see what we have. So now we just have 2x minus 10x. I think that is now out of here. That, and then plus 2y plus 8 squared. Okay, now we have that. If I can find where it was. Okay, let me do that again. So we have our 2x plus 10, negative 10, actually, sorry, squared, and our 2y y plus 8 squared. Oh. Okay, doke. So now, let's get rid of some of this stuff here. So we can see what we're working with better. Okay, so now we see here that we have 2x minus 10 squared plus 2 times y plus 8 squared, and this all equals 8. Equals 8. Okay, and right now it's not looking like it's going to go down right, because the square root of 8 is something that we do not like. But one of the final steps we have to do here is we have to divide this all by 2 to get this even here. So these cancel out, and these cancel out, leaving 8 divided by 2, which is going to be 4. So now we have x minus 10 squared plus y plus 8 squared equals 4. So let's rewrite that whole thing again. So x minus 10 squared plus y plus 8 squared equals 4. Okay, Doug, and that is going to be our answer here, and we can look up here, and that's going to follow that, how we have it. The equation, we have our 4 equals our x minus 10 and then squared plus our y plus 8 squared. And then so now we're done with circles. You should be able to do any of that with a circle. Be able to take this and turn it into the equation of a circle, and then we have the knowledge now to figure out how to graph that once we have the equation, or we can take the equation, we can take the graph and tell you the equation of it. So now we're ready to move on to ellipses. And the equation of an ellipse is a lot like a circle. Here it is right here. I should have blown it up. But it's x minus 8 squared plus over a squared plus y minus k squared over b squared equals 1. So what's the difference here? Well, we can tell here that this is basically a circle here, but it's like it's been stretched. And that's here. See, if we were to look at the equation of a circle, it's basically the same, except for there's nothing in the bottom here, because that's been moved over here. Because if we were to keep these 2 here, those 2's we had from this equation, that's basically its stretch factor there. They're still being stretched by the same thing, though. So we would have been able to know that this would have been an ellipse instead of a circle if, say, this was a 3, or this was a 1, this was just x squared, and this was 2y squared. So it's basically, an ellipse is just a stretched circle that the y and the x's aren't being stretched the same, where in the circle they are, because they're the equal distance from every point. But in an ellipse, we have instead of the radius, we have the foci, and the foci are going to be the points in an ellipse that are the equal distance from every single other part of the ellipse. So I can find a point in here, and if you add those together, it's going to equal the same thing if I was to find another point. So let me explain that a little bit better. So that's why we have this point right here on the ellipse. And then the foci was somewhere right here. And there should be another one right over here. So we get this kind of thing right here. And the sum of those two things is going to be the exact same at any other point in the ellipse. So from here to here and here is going to be the same as this one here. These points here and here are going to be the same all the way around the circle. And that's how you know it's an ellipse and not some weird formed circle, that ellipse type like thing that looks like an ellipse. Okay. So now that we've gone over that, so let's find on this ellipse, let's find some of the key things we need to know about an ellipse. And I'll go further into it later. But right now we need to find the center. So on this graph we see we have 1, 2, and 3. So it's 3 over and 1, 2. So the center is going to be at 3, 2. So let's get the handy dandy text box out and we'll write that down. 3, 2. Put some parentheses on that. And let's change it to purple. Or something like purple. Okay, so our center is at 3, 2. So now we need to find the length of the minor axis. Now the minor axis is going to be the axis that is stretched the least. So here it's pretty easy to tell. So this one here, we have this right here is an axis. And this right here is also axis. So it's going to be the shorter one of those two. And it's pretty easy to tell. It's this one right here. So this shorter one going vertical. So we can tell that it's 1, 2, and then another 2. So the whole length of the minor axis is going to be 4 units long. Okay, pretty easy to find there. Okay, now the major axis. Okay, so we have, this is from going from -2 to +8. Let me mark that out for you. This is -2 and this is +8. So add those together. If you were to add 2 and 8, that would give you the whole length. So that's 10. So let's get the text box back out. 10 units long. Okay, so now we actually have enough information that we're going to be able to form the equation of this ellipse. So we know that, let's apply this, that the center is at 3, 2. So let's start our equation. So you can see the equation up here. We have parentheses x, the opposite of our x. So our x right now is 3. So we're going to have to put that as a -3 because you can't trust them. You can't trust what they're doing, so they're the opposite of what they're actually doing. So -3, which will go over there, will be your +3 squared. Then we're going to have the y part of it. So over here on the y part of the equation, or after we add them together, we have y, the opposite of 2. So the opposite of 2 is going to be -2. And then we have that squared. Because it would look like you were going to graph it right here, but it's actually going to be up here is going to be the center. So first we have that part there. Now we can find the stretch factor. So the stretch factor on these two are going to be determined by the axis here. It's not going to be the whole length of this. It's actually just going to be half the length. So for our minor axis, which is also our vertical axis, it's going to be 2 long. So 2 squared in this case happens to be 4. So under that we're going to put 4. Let me add in a little division line for these here. Okie doke. Now, one thing I forgot to mention is if this was to be stretched more in the vertical direction, the y squared and the y component would have to go ahead of the x component. Okay, so now we're going to move on to the length of the major axis and figure out its stretch factor and what's going to go over the x component. So half of 10 is 5, so that's going to be the length from here to here, so half the length of the major axis, and 5 squared is 25. Okie doke. So now we know the equation of this is x minus 3 squared plus y over 25 plus y minus 2 squared over 4. That's not all yet. We have to add in what it's equal to. And all ellipses, if it's an ellipse, is going to be equal to 1. Every single ellipse is equal to 1. And that, like I was talking about earlier, has to do with how, in the difference between the circle and the ellipse, is that over here you have the radius squared, whereas that you do not. So we have the 1 there to deal with the stretch factor. Because instead of having the stretch factor, we have how far it's stretched each way. So instead of having the radius, that's what we have. Okay. So once again here, we have, this time we have an equation of ellipse. So we're going to graph this. So we have it as showing positive 2, negative 3. This is going to be the opposite of what they're showing. So positive 2, x is actually going to be negative 2, because it's like those couples, those high school couples, you can't trust them. And then negative 3 is actually going to be up 3. Okay, and now we can find the length of the axis here. So I didn't even notice this happen, but these happen to be very similar. So we have 25. So 5 squared is 25. So the square root of 25, to repeat myself, is 5. So that's going to be the length of the x component here. 1, 2, 3, 4, 5. That's one side of it. 1, 2, 3, 4, 5. So that's the other side here. Okie doke. So now the y is being stretched, has a 4 there, so 4 squared is 2, and that's how far it's going to go each direction. So 2 up here, and then 2 down, and I'm going to do my best to fill this in. Okay, so now let's get another graph for this one here. Okay, it'd be a lot easier to do if we have a visual representation. Okie doke. So over here, we know that the center of this ellipse is at 3, negative 4. 3, negative 4. 1, 2, 3. 1, 2, 3, 4. Okay. And then we also know that the vertex, one of the vertex is going to be at 321. Okay. So 321. That's going to be way out here. So let's just make that a little dot out there. Okay. But we'll be able to figure it out without having to have the whole graph. And then our co-vertex is going to be at 10, negative 4. 1, 2, 3, 4, 5, 6, 10, negative 4. And yeah, I graphed that one wrong there. So we have to say this vertex is going to be at 321 way up here. Okay, doke. So the ellipse is going to be really big. It's going to be something. Let's try that again. And it's going to come. And yeah, that's not very good, but you get the idea. Okay, so to find here, we can take the center here, and we know that the vertex of this 3 here is 10. It's 7 away from the x vertex is 7 away from. Oh, okay. Okay, sorry guys, this actually, it should have been up here. That's what was. Okay. So, we know that this vertex is 10 away from, is 7 away. So we know that since that's there, the stretch factor is going to be 49 for under the x component. And then for the center, we can find that negative 4 and the 21. So that's actually 21. That's 25 away there. So 25 squared is 625. Here, let me check myself. 625. So 625 is going to be under the y. So it's very clear to tell now the y is stretched way more than the x. So the y is going to go first. Okay. So now we can just add in the center. So y, because it's going first, because it's stretched the most, is at -4. So since it's -4, we have to flip it because it's going to be behind closed doors. And then we have it squared. And then we have x -3, because it has to be flipped, squared. And that is going to be our answer once we set it equal to 1. And that is the equation of this ellipse here. Thank you for watching, and if you have any other questions, please post it in the comments below, and I will make a video as soon as I get to it.